Assalamualaikum and a very good morning to all IPCME attendees. In Malaysia, about 97% of our water resources are derived from surface water, primarily rivers and such. Rivers runs free and its network is fast. It is important that we ensure our water resources are free from contamination and pollution. So why am I telling you this? My objective with this presentation is to provide an alternative solution to water monitoring system to collect data of the water parameters via cloud application. Water pollution in Malaysia is a serious problem and impacts negatively to our water resources. So the resources that we do have should be monitored at all times. So how can we design a water monitoring system that can be deployed for a long time, collect data consistently, and yet still be affordable? So the water monitoring system that we're designing sends data through cloud application. The system is designed for long-term deployment in remote areas where frequent data collection might be difficult. The system is low cost and it's versatile, as you can swap the sensors or add more according to the user's need. The data collected can be viewed directly through the internet. So as displayed here on the slide, this is the architecture design of the system. The components that are placed within the purple squares are deployed into the environment. There are two ESPs here being used. One, which is the one deployed, we will call as the sender, and another one connected to the Wi-Fi is called the receiver. Now the sender is directly connected to all these sensors and it is powered by rechargeable battery and also solar panels. So once the sender collects the data at specific time intervals, it will send it to the receiver using LoRa connectivity. The receiver would then upload the data received into a Google Sheet via IFTTT server. So it connects to the internet using Wi-Fi connection. If a user connects their device using the same Wi-Fi, they can view the data directly using an IP address displayed on the receiver. As you can see in this slide, the OLED display of the ESP32 has an IP address written on it. With this IP address, you can input it to any internet browser, provided that you're connected to the same Wi-Fi network as the ESP. You will come across the web browser here. This web browser acts as a user interface. See, as you can see here, the readings that should be seen are the latest reading obtained from the sender, and there's also a download button right there which allows users to download the entire history of data collected, and there are also a couple of tabs available. Those tabs provide a visual graph of the readings. So with this system we have tested. The longest data transmission that we achieved was 897 meters. This system was tested on level ground. So what we discovered is that interference does occur when there is a concrete obstacle in between the receiver and the sender. Concrete obstacles mentioned here includes brick walls and buildings. So the solution for this problem was to place the microcontrollers on higher ground to reduce obstacles. So as a conclusion, the system designed works as intended. The data for the water parameter could be monitored remotely. As the data are stored externally, there is no worry of losing the data should the system fail at some point. The system is also equipped with an alert notice where they send emails to users should the reading that they obtain is out of normal range. So what comes next after this? designing shell for the system that is weatherproof. It will also be an additional bonus to implement sensors that also measure the chemical properties of the water, and it will be interesting to see the system be deployed for a longer duration of time and see how long it holds up. Thank you.